Okay. For line number 1, the header file stm32f4xx.h is specific to the stm32f4 microcontroller series. It contains the hardware register definition and macro to configure and control peripheral like GPIO. The delay millisecond function prototype is declared for a custom delay function. For line number 8 and 9, RCC is a reset and clock control. The AHP1ENR register is used to enable the clock for GPIO peripheral. For line number 8, for enable GPIO-B. For line number 9, for enable GPIO-C. Without enabling this, GPIO pin on port B and C will not function. For line 12 until 15, GPIO-B configure PB0 for PB7. Model configure GPIO pins as input 00, output 01 or alternate function 01. Clearing the lower 16 bit of model ensure that PB0 until PB7 are reset. Then 0 minus 000005555 configure PB0 until PB7 as general purpose output. For GPIO-C, configure PC9 and PC13. These pins are cleared in model to ensure they are in input mode. These pins are connected to button for mode selection. For variable in count blinking and count up active, if count for track the current step in the LED sequence. For count blinking, a flag that activate the blinking mode, and count up active for a flag that activate the count up mode. And for line 22, the infinite loop continuously monitor the button state and update the LED accordingly. For line 24 until line 27, the condition is GPIOC IDR and 0 minus 0200. Check the state of PC9. If the button is pressed, blinking mode is enabled. For the action is count blinking is set to 1 to indicate blinking mode. The counter count is reset. A debounce delay of 2000 milliseconds prevent erratic behavior from mechanical button press noise. For line 21 until 42, for blinking pattern, LED toggles on and off to simulate a blinking effect. For GPIO-B ODR 0 minus 3F set PB0 until PB5 high means all LED is on. When GPIO-B ODR 0 minus 00 set LED is off. The sequence repeat 3 times, total 6 steps before stopping. Thank you.
So the second condition will start at else if GPIOC IDR and 0 times 2000. The coding this coding state that if precipitating button is pressed, this will active low. So after the button is pressed, count up active equals to 1. So this will activate the count up sequence for second condition, and then count 0 equals to 0. This coding will reset the counter for count up sequence, and then there is a delay MS to 100, which is the delay for the button after it press. So the delay will be 0.2 seconds. So after the precipitating button is pressed, so it will execute the count up mode sequence, and then it will start by if count up is a count up active, which is equals to 1. So we are using switch case function. So switch equals count. So you start from 0, and then there is a 0 until 5 case. So 0 case that used for turn on LED segment A. We are using for this switch case we are using GPIO-B ODR for the output. So from case 0 until case 5, for the case 0, it will turn on segment A, LED segment A. For the case 1, it will turn on LED segment B. And then for the case number 2, it will turn on segment A until C. And then for the case 3, it will turn on segment A until D. And then for the case number 4, it will turn on segment A until E. And then from the case 5, it will turn on segment A until S, which is it will display the character O. So after the case 5 is activated, the count active will equals to 0, which is it will reset, it will stop the count out, and then the default which is we show for the 0 times 0 0 is if there is an error, so the 7 split display will show none non-LED will be turned on. And then for the delay MS300, which is a delay for the sequence from 0 to B and then until AF, this delay will be 0.3 seconds. And then the count plus plus is a increment for the count up sequence. And then if count not active past the 5, the countdown active will be 0. So which is after the countdown active will be reset to 0, will be reset after it complete the count up sequence, which is it passed the case 5. And then next for delay ms integer n, so we are using a delay ms, so this is for declaration for delay ms, and then integer n, integer I, and then integer j is for declaration for a, and so I'm sorry, for n, I, and j. Volatile is a variable declared to prevent the compiler from optimizing out its usage. And then for the for the outer loop, which is n increment, and then for the for I equals to 0 and I less than 3523 is a inner loop. This is counts is a increment 2, and then j plus plus is increment for the and then increment j to control cycles and prevent optimization. That's all from me.
For the first condition, the switch 0, which is the external switch, is connected to PC9. And when switch 0 is pressed, it will display character O in blinking mode. For the second condition, when switch 1 is pressed, it will display character O by lighting up the segments one by one.